So on the packet, we would start, and I'm only going to do like the first three, so if, I'm not going to bore you with this, but, so family or group 1 for hydrogen. Number of valence electrons, 1, and then the Lewis dot structure would look like this. 1 electron. Then we're going to go down to nitrogen. Number 7. Family 7. Number of valence electrons, 5, right? And then nitrogen would look like this. 1, 2, 3, 4, 5. This gives you the 3p electrons that are unpaired. Hund's rule. Okay? And then let's go down to silicon. Number 14. So family or group, silicon is 1, 2, 3, 4. Number of valence electrons, 4. And Lewis dot structure, silicon, 1, 2, and then 2p electrons that are unpaired. Now, if I wanted to do, I could do chlorine, or I could do sulfur, which is 16. So that would be family 6 or 16. You could do 16 if you wanted, because, it depends on how you look at it, right? Number of valence electrons, 6, and then sulfur, 1, 2, 3, 4, 5, 6, leaving 2 unpaired electrons. All right? Questions? All right, so let's move on to the next page. All right, so valence electrons for each atom. Let's start with water. So I have hydrogen has 1 and oxygen has 6. Total number of valence electrons, 2 times 1 is 2. 1 times 6 is 6, so that's a total of 8. So now I'm going to put my hydrogen, my oxygen, my hydrogen, and then my hydrogens are fine. Notice my oxygen is in center because I'm making a wheel. 4 pairs, and I can say 4 pairs. Okay, let's go down to number 6. Any questions? Number 6, CH2Cl2. Carbon has 4. Hydrogen, 1. Chlorine, 7. So I have 2 hydrogen, so 2 times 1. 1 carbon, 1 times 4. 2 chlorines, so 2 times 7, 14. So that's a total of 20, which is 10 pairs. What's going to go in the center? Carbon. The lowest electronegativity. All right. That's going to be carbon. Now, my preference in this, and I know I see you think it's chlorine, right? No?
I'm just confused.
Why?
Why does chlorine have a higher electronegativity? Like,
Because it only needs one electron.
Oh.
Right, and carbon is a covalent sharing, right? But so, and that's why I'm saying my preference in this is to always think that I'm making a wheel. The other thing is chlorine only needs one electron, so it's only going to make one bond. It's not always terminal, as you're going to see, but in this case, it's terminal. So, also, the lowest electronegativity is written, remember cations, we like cats, we don't like onions. So cation, the cation is the lowest electronegativity, so it's always written to the left. So the cation, the lowest electronegativity, is written to the left. So it is written the way that it's, what am I saying? I'm thinking. I'm not staring at you, I'm thinking. So, yes. Well, you can't really say that because oxygen, nitrogen, oxygen, and fluorine have very high electronegativity. So I'm trying to follow through on what Sabrina just said. Chlorine only has one bond, so I think that it's best to think you're always making this wheel, and the lowest electronegativity is always to the left here. It always comes first because it's the cation. The cation, the way it's written is that the cation is always to the left. So when we look at this one down here, well, this one doesn't matter because it's a straight line. I'm looking to make sure. Hang on. I'm trying to give you an answer that you can follow because I like rules, right? So if we look at this one here, well, that would work. Carbon is to the left. Carbon is a 3.1 and chlorine is a 3.5. So it does work that carbon has a lower electronegativity. And the reason is because carbon always is covalent and always shares electrons, and chlorine, what happens is the one energy level that's down one doesn't account for the fact that chlorine is 3 to the right and wants one more electron. The electronegativity for chlorine to have the increase in protons needing one more electron to be full, with 2 full p electron orbitals only needing one more electron is stronger than chlorine, which has 2 open spaces there. Also, which we don't know yet, but we will know next, carbon has 4 open because carbon is a very unique situation. So, like, this is weird that we're having this discussion. But carbon has 2s2 and then 2p2. So it has this. And what happens, the reason carbon is so unusual is because what happens is carbon hybridizes. And so what it actually creates when it bonds is it creates an sp3 hybridization, which is why carbon always bonds with 4 bonds. It's the only one on the periodic table that does this. It's not the only one that hybridizes at sp3, but with its second energy level and the sp3 hybridization, it has a 3.0 electronegativity and 4 open energy levels. So with chlorine at a 3.5 electronegativity and 1, which is high, and 1 open energy level, it has a higher energy level, a higher electronegativity, whereas carbon has a low electronegativity of 3.0, yeah.
Is that something that we were expected to know for
Right now?
just Tuck?
Right now? No.
Right, Tuck.
No.
Okay.
There wasn't really any reason for you to know that on the test. It wouldn't have changed anything, no.
Yeah, but I thought the energy level like always trumps.
Well, it does, but there wasn't any question that you would have needed to know that carbon was higher than chlorine.
Oh, carbon's the exception to that.
That carbon is lower than chlorine, no,
Oh, okay.
no. Mm-mm. All right. No, so nitrogen, oxygen, fluorine are the highest on the periodic table. So it makes sense, they're equal, nitrogen and chlorine are equal and they're the highest, so, yeah. All right, so let's go back to, so this is written, if we look at number 6, this is written lowest to highest. If we look at number 8, it is written, so oxygen, so it is written lowest to highest. Oxygen is lower. It's written lowest to highest. It is written lowest to highest. All right. You did not need to know this on the periodic table because it would have all worked out in the questions. I mean, I'll double check, but it would have all worked out. I think that on the test, the energy levels were far different, if that makes sense. So I'll double check, but I'm pretty sure. Okay. Okay, so we're going to put carbon in the center. We're going to put hydrogen, chlorine. It doesn't matter where you put them. Doesn't matter where you put them because we're not there yet, so it doesn't matter. We're going to put 1 in between each one. And we have 10 pairs. Hydrogen is set, so that's 4, 5, 6, 7, 8, 9, 10. We're good to go. Now, if I do this one, right, I have oxygen with 6, hydrogen with 1, and chlorine with 7. So that's 7 and 7 is 14. That's 7 pairs. I'm making a wheel. My chlorine can only have 1 bond. My hydrogen can only have 1 bond. My oxygen is going to go on the center. My hydrogen is good. My oxygen is not, and my chlorine is not. So 1, 2, 3, 4, 5, 6, 7. I'm good.
For number 6, do the 2 chlorine and the 2 hydrogen need to be like on the opposite side?
No, it doesn't matter where you put
like
them.
One, like the 2 hydrogen and the 2 chlorine here.
Fine.
Okay.
Okay, let's look at number 11. This is an ion. So I've got 3 hydrogens, so that's 3 times 1. So that's 3. 1 oxygen, so that's 1 times 6, so that's 6. So that's 9 minus 1, because I'm taking away 1. So that's 8, which is 4 pairs. My hydrogens are terminals. So I'm going to put my oxygen. I'm going to put my hydrogens around. Does it matter where? No, I'm just putting them equidistant. 4 pairs. My oxygen is not happy. So here's my fourth pair. I'm going to draw my bracket. Plus sign. Yeah, Ella.
On the homework, there was an example that said like CA2+. How do you draw something like that?
So Ca2 plus is going to be calcium losing 2 electrons. So calcium looks like this. So losing 2 electrons would look like this. Because it has 8 electrons underneath, but we don't draw them. Yeah.
So because you minus electron, outside of brackets you do a plus sign, you can do that.
Yes.
Vice versa.
Because this means that I've lost 1 electron, and vice versa. Right. So if I add 1 electron, I'm going to have a -1 outside the bracket. So I'm telling my readers that I have enough electrons to draw this picture because I took 1 away. All right? Okay. So I'm going to leave you